The 18-meter logistics gap. Starship will deliver 100 tons of mission-critical hardware to Mars in 2028, but it arrives with a significant mechanical constraint. The cargo is suspended 18 meters above the landing pads. If the newly designed Mars unloader fails, the mission ends with 100 tons of high-value scrap metal that cannot reach the ground. This transition from orbit to surface is currently the most underestimated risk in the 2028 flight profile. Solving this requires a departure from the light-duty systems we saw on the HLS lunar prototypes, because Mars gravity introduces specific mass transfer dynamics. Mass transfer in lower gravity. The 2028 Mars unloader is a dual redundant gantry system designed to handle 38% of Earth gravity loads while maintaining ship balance. Think of it like a warehouse crane operating on a tripod that is 50 meters tall. Unlike Earth-based gantries, this system must deploy autonomously on unknown terrain with a maximum tilt tolerance of only 5 degrees. This engineering shift confirms that the Mars variant is no longer a derivative of the moonship, but a distinct heavy industrial platform. This leads directly to the problem of keeping the entire 1,200-ton stack upright during the process. The static stability constraint. Static stability is the primary constraint during the unloading phase. As 100 tons of equipment slides out of the payload bay, the center of gravity for the entire 50-meter stack shifts laterally. If the deployment rate is not precisely synchronized with the landing leg hydraulic compensators, the ship risks a tip-over event that would be catastrophic for the primary hull. Recent data from the Starbase vacuum chamber tests suggests that the friction coefficients of the cable guides are higher than initially modeled, requiring a 12% increase in winch motor torque. However, torque is useless if the cables are shredded by environmental factors. Regolith, Ingress, and cable fatigue. Mars regolith is the silent killer for these mechanisms. These cables must survive hundreds of cycles in a high CO2 environment, where abrasive electrostatic dust acts like sandpaper on the pulleys. SpaceX is currently testing a new polymer-coated tether to replace traditional steel, aiming for a 40% reduction in friction while maintaining a 5-to-1 safety factor. The signal under the noise. The engineering of the Mars unloader proves that the success of the 2028 window depends on material handling, not just orbital mechanics. By moving from the personnel-focused HLS elevator to this heavy-duty gantry, SpaceX has acknowledged that the 100-ton cargo claim is a liability until the vertical logistics are solved. This focus on mass transfer and regolith mitigation directly addresses the two biggest failure modes identified in the 2025 Starship post-flight reports. For mission operators, this means the first Mars landing site will be chosen based on ground flatness for unloading stability, not scientific interest or ice proximity. The real signal is that SpaceX is prioritizing industrial throughput over exploration targets to ensure the 2028 arrival leads to a functional base rather than a graveyard of inaccessible hardware. Watch for the full-scale deployment test at the Cape this September to see if the winch assembly can handle the offset load without structural deformation. Subscribe for more.